Hey there, please before you watch the video, do us a favor and subscribe to our YouTube channel. Hello and welcome to this video. This is a simple tutorial on how to use a breadboard for absolute beginners. So if you're interested, please keep on watching. We'll cover a few basics in this video, such as what a breadboard is, why it's useful, parts of a breadboard, connected and unconnected holes, component placement on a breadboard, avoiding common mistakes, and then we'll assemble a few basic circuits. So if you're ready, let's begin. Simply put, a breadboard is a tool used to build and test circuit prototypes before they are permanently soldered. Benefits are no soldering is required, it's easy to assemble especially for beginners, no permanent connections are made so it can easily be disassembled, and of course breadboards can also be reused. It comes in different sizes. On the screen here I have the normal size, the big size and the extra small. The two rows on the top and the bottom are known as the power rails. These are where you connect the negative and positive terminal of your batteries to, and all sizes have it, though they might not look the same. Every hole in that section is connected, so all the holes on the positive and all the holes on the negative are actually connected. Similarly, every hole on the same column in the middle section is connected. So that way, if you plug two components and the two leads of the two components lie on the same column, then those two components are automatically connected. And this goes for all the breadboards irrespective of their sizes. Next, let's talk about component placement. It's best practice to connect all your components in a way that all their legs lie on different columns. For example, rather than connecting your resistor vertically, connect it horizontally, so that way you can connect other components to both legs of the resistors by simply placing them in the same column. Same goes for the LED. But for the push button switch, it has 4 legs and 2 of those legs will ultimately lie in the same column. So to avoid this, it's better you place it in the middle as seen. That way each of the 4 legs will lie on individual columns and the connection will be easier done that way. 5x5 timer has a similar layout. It has 8 pins, 4 on each side, so it's better you connect it on the middle of the breadboard also, so that each of those 8 pins can have separate columns to connect the different components. Batteries are typically placed outside the breadboard and the negative and positive terminals are connected to the negative and positive rows on the breadboard respectively. Similarly, if you want to connect components to either terminals of the battery, you simply connect those components to those rows. That way they're automatically connected to the battery. Next, we're going to talk about some common mistakes you should avoid while using a breadboard. Aside incorrectly placing your components, you should also avoid improper use of resistors or not using resistors at all. For example, I connected this LED directly to the battery without using a resistor, and it's going to give us an error message telling us that the current we are putting in is too much, so we need to resist some of the current. Now when I used the resistor, it came on just fine. Another mistake you should avoid while using a breadboard is poor power and ground connections or poor connections in general. So in this simple LED with the push button switch circuit, I connected the switch to the battery wrongly. That was why the LED wasn't coming on despite turning on the switch. When I corrected it, it still didn't turn on. That was when I realized that my resistor was improperly connected to the push button switch. So the moment I rectified it, voila, it came on. To complete this video, we are going to assemble 2 basic circuits on the breadboard. The first one is an LED circuit. I have about 7 LEDs connected in parallel, and the way to connect it in parallel is to simply connect the first cathode to the second cathode to the third cathode, and so on and so forth. And do the same thing with the anode. Then connect your resistor to your power source, which is the positive terminal of the battery, and connect the anode of the first LED to ground. The second circuit is going to be an RGB LED that is controlled by 3 switches. The first switch controls the red light, second the green light, and the third the blue light. We'll connect the outer legs of all the switches to the positive rail of the battery. Then we'll connect the middle leg of all the switches to the first, third, and fourth terminal of the RGB, controlling the red, green, and blue light respectively. Finally, we'll connect the cathode of the RGB to the negative terminal of the battery and connect our battery. As expected, the first switch turns on the red light, second the blue, and the third the green. But we have a problem, which is excessive current. And how do we solve that? If you guessed using a resistor, then you are absolutely correct. By placing a resistor in between the positive terminal of the battery and each of the switches inputs, we can minimize current flow and make our LEDs to shine normally without getting burnt. That's it for this video. If you enjoyed it, please give it a thumbs up and subscribe to our YouTube channel. Also leave a comment below on your experiences while using a breadboard. You can also check out the description for our Rec 1 and Rec 2 products to begin your electronics journey.